Hi guys, Cam at Battler back again. I mentioned in a previous YouTube video that I was designing up a little slotting attachment for my lathe, and I'm probably about 95% completed on the design now, and I'm going to make a start on the build. So over the coming months you're going to see YouTube clips of the various componentry that we make up to put this unit together, and then hopefully at the end of it we're going to see a working machine. But I might be setting myself up for failure here, but let's see how we go with it anyway. As I did mention, it's going to be varied for the center height of various lathes. So the idea being that we can move the ram up or down to suit a particular center height for a lathe, but then we can also move that ram up and down to actually side cut, a key way to open it up if you need to. So I've designed this from the top of the saddle to the center line as an absolute minimum. That's 80.5, as a maximum up to 43, but you've got the opportunity to be able to put packing underneath it if you wanted to lift this up further, if the swing on your lathe was a little bit more. Plan to put a little digital readout on here, or a dial indicator, so that when you are side cutting you can accurately move this up and down via this little hand wheel here to get your position just right, and you can check your gapping, your cut with your gauge box, and adjust accordingly. So looking at this little unit, it's driven by a little 0.18 kilowatt motor, and I've actually got a three-phase motor that I bought, and that cost me around $80 delivered, and I'm going to hook that up to a little variable speed drive that I've got initially to get the stroke rate just right. I'll take a bit of a punt on my timing belt pulley sizes to set a ratio, but it's nice to be able to fine tune, and what I'd like to be able to do is put a single phase motor on here, fixed speed, once I know that that stroke rate suits the way that I like to machine. So envelope size, look, it's fairly compact. We're looking at 270 wide, tad over 300 high. That will go a little bit higher obviously with a single phase because you've got the cap box sitting on top of it. But it's going to be a fairly compact little unit. Slotting is one of those things that you do fairly infrequently, but if you can do it, it certainly opens up other avenues for what you can do in your workshop. It adds another dimension to your model making or your manufacturing. And the plan on this one is, because slotting is done so infrequently, to have a dedicated piece of gear sitting on the floor, and my workshop is reasonably small. I don't have a lot of floor space. It's at a premium. To have a little unit that I can pull out when I need to, do the job, and then pack it up and put it away in the cupboard for the next time, suits the way that I've got my workshop set up. Let's have a look at the drawing and how I've laid this out. So we've got a front elevation, we've got two side elevations, we've got a rear elevation, and we've got our plan. On the GA I've cut section lines at various points, and I do a separate sectional arrangement to show what is going on inside. So that's my sectional drawings there, and from those sectional drawings I like to blow up bigger details. It makes it so much easier for the fitter or the manufacturer to see exactly what's going on, and you can put notes around here about how you like to have things set up as well. So, you know, drawings can run for 5, 6, 7, up to a dozen sectional arrangement drawings, depending on how far you want to break it down. And it's something that I like to do. I like to get as much information onto the drawing as I can without trying to make it too busy, to give the fabricator as much information as I can. You know, the drawings are basically like a storybook. You need to make it as easy and as understandable as you possibly can, and you need to break it down as best as you can to show the information that you need to get across. So I've got a number of main sections that I've cut on this, and then I've taken off larger details just to show a bit more information. But basically the way that this unit's going to work is our electric motor is going to be driving down onto our worm wheel, our worm, which then drives our worm wheel around, which has a crank disc attached to it, and on that crank disc we've got our crank rod attached. And I've got various positions for that crank rod that we can attach it to change the stroke length. So I've got 3 separate positions, and I think the maximum I've got on there, I think we've got a maximum stroke of 75. I think I go down to about 30 millimeters as the minimum stroke on the smaller radius. And that can be adjusted via this little pin here. So this little pin here, we've got an orifice hole, which is through our slide plate that we can get access to that pin. We can unscrew that pin, move our slide plate up and down, rotate the crank disc around, and then reposition it into a different stroke position. The worm wheel I've got attached into what I call a cartridge, and I like cartridge design. I like it so that we have separate sub-assemblies that you can take apart and work on a bench or assemble easily and then put into the main assembly. It's very, very hard for fitters, maintenance people, if everything's machined in the one show, to try and get things apart or try and set end floats or try and do basic repairs. It gets very, very hard sometimes and very, very frustrating. Trying to work on gear that doesn't come apart easily and doesn't go together easily. So I like what I call cartridge design. So this assembly here is a separate sub-assembly. So this is the main shaft for the worm wheel, and we've got our bearing assemblies on there, we've got our lock nut assembly on there, we've got our own seals on there, we have our own lubrication system on there. So it's a completely separate sub-assembly from the main assembly, if that makes sense. So that little sub-assembly goes together, and we can then introduce our worm wheel into it. It also allows you to set very easily the center lines to get them spot on. So we can either take a little bit off that face, or you can shin that face to move that sub-assembly backwards and forwards very, very slightly to get that right. So I like sub-assemblies. I like the cartridge design. As I said, makes life so much easier. Over here you can see the worm itself engaging in the worm wheel, and once again I've got a little blow up here of those bearing assemblies that we put into place. So fairly straightforward. I used taper roller bearings and used the lock nuts with the tab washers to lock into place once you've got the preloading set. This particular one up here, we've got a circlip that then locks it up, becomes a thrust place. Larger assemblies, I've used split rings with shrink rings over the top to create a shoulder for large bearings to push up against, to preload onto. You can see the section cut here, which is section EE, which is where we're cutting right across the positioning nut and also the main slide. So you can see we've got that as a dovetail arrangement there. And to lock that into place, once you've got your height positioned, I've just got a series of grub screws similar to the tube boring heads that you can buy. It's just a slit with a grub screw, and we just push up against the dovetail, which then forces and locks it onto the slide, which keeps it in place. So fairly straightforward, nothing real fancy on that. Slide arrangement up here for the ram. I've got adjusting pads, if you like, that we can adjust the float and the tension that we put onto that ram to make sure that there's no way in the world it's going to be rattling around inside the main housing. I've got a shear pin assembly. Something I like to do with designs is, well, when we are designing, you always try and design around the motor failure, and the motor failure you commonly want is the motor to stall out before you break anything. Sometimes you can't do that depending on the type of gear that it is. Sometimes there's inertia issues, sometimes there's intensification issues. There's a whole range of issues that mean that the motor isn't the component that is going to fail or stall. You don't want it to fail, you want it to stall and trip out. So I've got a shear pin assembly inside here. The last thing I want to do is have something ramming into my headstock, and I've made a mistake and I've engaged it too far, and the head goes forward and thumps into the chuck. So I've got a shear pin assembly here that works between the crank and the ramrod, just in here. We'll see a better picture of it up here. Here we go, here on this plane elevation here. So that's a shear point through there. So I've designed it so that if you do shear it off, it's just a bit of all thread that will machine down. I think it's 2.5 millimeters. I've done the numbers for that I want to work on. I'll see how that assembly goes. It's got some little split collars here to make that easy to assemble, and it's just fastened up and fixed off with a couple of M6 nuts. So that'll be the shear point through there. If it's too fiddling, too awkward, I'll just go for a bolt-in type one that will machine down with a radius, same as what I've got on the slotting head that I've done for the milling machine. Let's have a bit of a look at how I arrange my drawings, and this is a bit of this is the way I like to detail out. Other companies do it differently. I like to me, I reckon this is simple, and I've sort of tweaked this a little bit, working with various manufacturers and how they like to read drawings and how they like to garnish that information out through the fabricators. But basically, as I said, we cut sections to make it as easy as we can to see what's going on inside, how the unit gets assembled, how it gets disassembled, how it can be maintained. The next part we need to look at is how we itemise this, so we can look at the various items and how we're going to manufacture those and where they fit within our overall assembly. So I've got my item bubbles. So top little number gives the item number on the sheet, and the bottom number gives the sheet number. So this series is drawing 115, and this sub-assembly, or this sectional assembly, is sheet number 2. So for example, if we go to item 1 on sheet 24, if I can find sheet 24, there we go. So item 1 on sheet 24 is the adjusting screw, and there's all the details pertaining to that adjusting screw. Item number 2 on sheet 24 is our adjusting nut. So if we have a look there, you'll see item 2 on sheet 24, there's our adjusting nut, and I think I put that down on this section here as well, so there we go there. Item 2 on sheet 24, showing that. So the idea being that very, very easy to garnish the information out, go to the particular detail, you know how it fits within the assembly. Proprietary items, so that's how I do my detail bubbles. Proprietary items I do in lowercase. And these are the items you're going to go and buy from your suppliers, so whether it be bearings, whether it be all your fasteners, whether it be your timing belts or your timing gears or whatever, your motor, all that information pertaining to those purchases are on that item list. So, you know, we can look at what we've got. Item U, you got an item U, we need 8 of them. It's a socket header cap screw, it's an M6 by 30 millimeters long. Item V, same thing, 4 if required, so I've got a cap screw and M5 by 12 long. So we try and make that as easy as we can. Now I've got a few little mistakes in here that I will fix up as I go through. All the part numbers that pertain, particularly, like, for example, the bearing. So we go to the sectional assembly here, we can see item A, it's a bearing. Details on the bearing. Often I'll put if I have a preferred supplier who I want to use for that, maybe Timken or an NSK, I'll put the manufacturer on there, but always put a part number, and they're a generic part number, or they're an ISO part number, so they're interchangeable between various manufacturers to a large extent. So that's the item list that I put together. Right, I have worked on drawings in the past where you basically need a code book to work out where the item is and what particular sheet, particularly if it's a drawing set with 2,500–3,000 drawings in it. And I find the Japanese drawings probably the worst in that way. If you lose the code book, you're absolutely stuffed. Absolutely stuffed. One of the things I do like to do is on each of the assemblies is to put a full item list. I know there are design companies. One big one that I've worked with was United in America. They have separate, beautifully bound leather folders with all of the items that pertain to a particular drawing. So you don't get the information on the actual manufacturing drawing. You have to go to the bill of material or to the itemised lists that are in those beautifully bound folders, and that system's fairly easy to follow because they do actually have the folders set up with the drawing number and the particular sheets that go with it. There may be multiple drawing numbers that go with a large design, and yeah, but I like to put as much information as I can without making the drawing look too busy. As much information as I can for the fabricator, so he can see, you know, the main housing on this particular unit is an RHS rolled hollow section, 150 by 100 by 6 length. So he's basically got a cut list there for everything he needs to make that particular component on that detail. All right. Well, I guess we'll start at the start, and we'll start our first fabrication, which is going to be item 1 on sheet 3, which is going to be our housing. So, as I said, that's just a bit of RHS that we're going to use for the main housing. We've got a couple of side plates. Tends the machining reference to come back to, but item D, if we have a good item D, it's out of 12mm plate, so I've allowed a 2mm clean up on that. We've got the main front plate, which is finished size 22, so if we go to that one there, which is item C, it's a 25mm plate, so I've allowed 3mm clean up on that one. And we've got a rear plate at the back here, which is this fella here, which is basically a ring. I've shown it up as plate, but I've got a bit of bar stock that I've got off an old axle, off a very old crane that I'm going to use for making that up. And then inside we've got a couple of bosses for our bearings. So the side plates are going to have these bosses pre-welded onto them before we put them onto the assembly, before we weld up the entire assembly. So once again, fairly basic layout with your plan. I've got 2 side elevations. I've got an underside elevation, and I've got my main plan, and then I've got my sections cut up so you can actually see how all that gets machined together. And then I've got a couple of little ISOs. It just makes it easier for the fabricator to get it into his head just how everything sort of goes together. And I've got separate little details here. These are just the clearances for the crank arm as it's rocking up and down. So I've already got the material set aside for this, so we might go out and have a look at that, and we'll see where we're actually going to start. So, all right, we'll catch you in a minute. All right, guys, let's have a look at the stock we've got set aside for doing this little housing. As we mentioned before, that the main body is out of a bit of RHS, a bit of 150 by 100 by 6 thick, 150 long. So there's a bit of stuff that I got from my metal suppliers. It was a scrap offcut, so I got that for scrap pricing. The front plate, which you can see up here, that's out a bit of 25mm plate. There's a bit of stuff I got from my scrapper. Looks like a dog's had a chew on the end of it, but I've got a good relationship with my scrapper. He tends to put stuff aside for me, and every couple of months I'll come in and have a look at what he's got, and anything I buy he gives it to me for a really, really good rate. These thicker sections, you know, if you had to go and buy them proprietary, you're paying a lot of money for it, and to get this sort of stuff, even though you may need it, you might not need it, but just to have it on hand, and you're buying it at scrap rates, saves an awful lot of money. So yeah, if you got a local scrap yard, get down there to your scrapper and have a yak with him and see if you can sort of put this sort of stuff off to one side. The boss we've got sitting at the back here, I've got that listed as plate, but I've got an old, this has been cut down a fair bit, I've used this a fair bit, but there's a part of an old axle off a crane that I got. Actually see where the lip seal used to rub it on it, but I got that from my same scrapper. He got a crane in, and he let me go in there and strip bits and pieces off it a long time ago, so that'll clean up for my the rear ring. We've got our little foot just here, so I've got a bit of 16mm plate I've used for a job in the past that we'll cut down, and we'll make that up. The side plates, they're out of here, 10mm flat, so I've got a job that I did ages ago, a little bit of offcut there, so I'll reuse that. And the little bosses inside, I've got a bit of 50mm bar stock there, a bit of black bar stock that we'll use for the bosses inside. All this is very rusty, obviously. It looks, it's been sitting out in the weather, or just gathered rust on it. So because this is going to be used for a gearbox, we will have to clean up the insides of this. So there's nothing wrong with this. You just get into it with a wire wheel or a wire brush and a flapper wheel, and it cleans up really well. So no issues with that. And I'll probably do an epoxy coating on the inside of this. If you ever open up gearboxes, you'll see all that precipitation, that moisture precipitation around the tops of the boxes, and you'll see all that rust that occurs because of that in gearboxes or in hydraulic oil reservoirs. You always try and give it some sort of a coating to give it some level of protection, because we are going to have a heavy gear oil, high pressure gear oil sitting inside here for the worm wheel. We'll see how we go with that. Alright, well that's everything to make a start. So we'll get into that, and we'll start cutting up everything first, getting that together, and then we'll start doing all of our pre-machining. So we'll be doing some pre-machining on this stuff. Always good to start with a good foundation stock that's nice and square and to size to start building off. If you don't start with a good foundation, you're always playing catch up on it. We will be putting some wheel preps in here, try and get some good penetration, because I want to try and maybe clean this housing back as much as we can. Makes it look a lot better. I'd love to, when I get my foundry up and going again, I'd love to do a set of patterns and core boxes to actually cast this out, whether I do it in cast iron or whether I did it in aluminium, but it'd be a good little casting project to do. But anyway, we'll do it with what we've got in hand, and we'll make a start on it. Alright guys, we'll see you soon.